Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about Gaussian distribution concept. The Gaussian distribution is a widely used continuous probability distribution function. Probability distribution. This Gaussian distribution is also referred to as a normal distribution. This distribution was determined as a limiting case of the binomial distribution. A random variable capital X. So generally the random variables are represented by uppercase letters. A random variable capital X is said to be a Gaussian distribution or normal distribution if its probability density function is given by small fx of x is equal to 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square. For x is varies from minus infinity to plus infinity and sigma is greater than 0. Capital X is a Gaussian random variable and its probability density function is given by or defined as this is the expression of the Gaussian probability density function of the random variable capital X. Now here in this equation x is small m is the mean value of the random variable and sigma square is the variance of the random variable. If the Gaussian distribution function has 0 mean and sigma is equal to 1, variance sigma square is equal to 1, then it is called a normalized Gaussian distribution function. It is given by and its normalized distribution function is given by. So in the above, okay, fx of x is equal, it is given by f of x is equal or capital fx of x is equal probability of x less than or equal to x. And what is this one? This is the definition of the cumulative distribution function. If the Gaussian distribution function has 0 mean and sigma square is equal to 1, sigma square is equal to 1 means sigma is equal to 1, then it is called as a normalized Gaussian distribution function. It is given by fx of x is equal probability of capital X less than or equal to x. Here this x is the random variable and this x is the value of the random variable. So x less than or equal to x mean that is minus infinity to x, integral minus infinity to x, f of x dx. But what is the Gaussian density function? The Gaussian density function f of x is equal to, this is the equation. So in this equation substitute mean value is equal to 0 and sigma square is equal to 1. We get the resultant Gaussian probability density function fx of x or f of x is equal 1 by square root of 2 pi sigma square is equal to 1 e power minus x square m is equal to 0 e power minus x square by 2. So that is the remaining expression of the after substituting mean value is equal to 0 and sigma square is equal to 1. Okay, that expression is f of x is equal to 1 by square root of 2 pi e power minus x square by 2. And substitute the density function value into this equation, we get the probability distribution function or the cumulative distribution function f of x, capital F of x or capital fx of x is equal 1 by root 2 pi integral minus infinity to x e power minus x square by 2 dx for x greater than or equal to 0 and x less than 0 f of minus x is equal to 1 minus f of x. The Gaussian distribution or the normal distribution is denoted as n of m comma sigma square. M is the mean value of the random variable and sigma square is the variance of the random variable. The representation of the Gaussian distribution or the normal distribution is denoted as n of m comma sigma square. So this equation shows that density function small fx of x reaches a maximum value at x is equal to m. It has points of inflections at x is equal to m plus or minus sigma. In the Gaussian density function expression. And what is the Gaussian density function expression? This is the equation of the Gaussian density function expression. In this equation, substitute x is equal to m. The Gaussian density function reaches a maximum value. And what is that maximum value? After substituting x is equal to m, substitute x is equal to m, x is equal to m minus m, 0, 0 by 2 sigma square, 0, e power minus 0 is 1. So at x is equal to m, the maximum density function value is f of x or fx of x is equal 1 by square root of 2 pi sigma square. So that is this one at x is equal to m. In this graphical representation, we can observe that at x is equal to 0, at x is equal to m, the maximum value. So at x is equal to 1, what is the maximum density function? 1 by square root of 2 pi sigma square, and x is value of the random variable, and y-axis is probability density function. So this is the shape of the graphical representation of the Gaussian probability density function versus value of the random variable. The shape of this curve, the density function fx of x mainly depends on the parameter sigma. So now here in this graphical representation, there are different values of the sigma. Sigma is equal to 1 curve, sigma is equal to 1 by 2 curve, and sigma is equal to 2 curve. So now here the shape of this curve mainly depends on the parameter sigma, and the curve is called the normal curve. And the curve is called the normal curve. The normal curve is bell-shaped curve. And the normal curve is the normal curve. That normal curve is a bell-shaped curve. This is the bell-shaped curve. The shape is the bell-shaped curve. And this bell-shaped curve is symmetrical about the line at x is equal to m. So this is x is equal to m line. At x is equal to m, the normal curve or the bell-shaped curve is a symmetrical about the vertical line. So that can be observed this figure and this figure. So this figure shows the normal curve with x is equal to m. We also see that for smaller value of the sigma, for smaller value of the sigma, the density curve reaches maximum value and the curve falls off rapidly. For the smaller value of the sigma, and this is a sigma is equal to 1 curve, and this is sigma is equal to 1 by 2 curve. Okay, for the smaller value of the sigma value reduces, the density curve fx of x reaches a falls off rapidly. And in this curve, m greater than 0, and this is m is equal to 0, vertical axis, m greater than 0, the curve is shifted to the right side, and m less than 0, the curve is shifted to the left. And positive values of the m greater than 0 means positive values of the m, the curve. And what is that curve? Bell-shaped curve. This is a bell-shaped curve. That bell-shaped curve is shifted towards the right direction, and for m less than 0, the curve shift to the left. Next, find out the corresponding cumulative distribution function of a Gaussian random variable. But we know that according to definition of the cumulative distribution function, capital Fx of x is equal to probability of x less than or equal to x, which is equal to integral minus infinity to x density function dx. So, but density function, Gaussian density function is 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square, and substitute that value here, we get this is the corresponding cumulative distribution function of a Gaussian random variable x. So now here from this equation, the solution of this integration can be in two different forms. This integration, the solution of this integration can be in two different forms. That are, first one is So we know that the property of the probability distribution function or the cumulative distribution function property, capital Fx of x is equal probability of x less than or equal to x, which is equal to 1 minus probability of x greater than x. So 1 minus, so probability is equal integral of the density function. Now here x greater than x greater than x means the range of x is x to infinity, integral x to infinity, probability density function dx. And what is the probability density function here? 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square. So 1 minus probability of x greater than x. So from this equation, let us consider x minus m by sigma is equal to p. X minus m by sigma is equal to p. So x minus m is equal, sigma is coming to the RHS side, x minus m is equal to p sigma. Differentiating with respect to x, dx is equal to sigma into dp. So now here, what are the values of the, what are the ranges of the x? X ranges are varies from x to infinity. Now here we are considering x minus m by sigma is equal to p. Now calculate the ranges of the p. In this equation, substitute lower value of x, then we get lower value of p, and substitute upper value of x. And what is upper value of x? Infinity. We get upper value of p. At x is equal to x, lower value of x, then p is equal to x minus m by sigma. And at x is equal to infinity, x is equal to infinity is the upper value of x. P is equal to infinity minus m by sigma. Infinity minus m, infinity, infinity by sigma, infinity. So therefore, the lower value and upper values of P are x minus m by sigma to infinity. And applying these considerations into this equation, we get the cumulative distribution function fx of x is equal to 1 minus 1 by square root of 2 pi sigma square integral. Now p ranges are x minus m by sigma to infinity e power. So now here x minus sigma, x minus m whole square by sigma square is written as x minus m by sigma whole square. But x minus m sigma is equal to p. So therefore, e power minus p square by 2 into dx. dx is equal to sigma into dp. So that is equal. Now here, square root of sigma square is sigma. So numerator and denominator, sigma is the cancel, and the remaining expression is capital Fx of x is equal 1 minus square root of 2 pi integral x minus m by sigma to infinity e power minus p square by 2 dp. We know that the expression of the q function q of k is equal 1 minus 1 by square root of 2 pi integral k to infinity e power minus x square by 2 dx. And this is the equation of the q function. This is the basic expression of the q function. Thus, q of, so now here in this integral, in this q function, and what is the lower value of x? K, q of k. So now here in this equation, and what is the lower value of p? X minus m by sigma. So from this q function expression, thus q of x minus m by sigma is equal 1 minus 1 by square root of 2 pi integral. So now here in this equation, k is replaced by x minus m by sigma. We get integral x minus m by sigma to infinity to e power minus p square by 2. So therefore, the probability distribution function or the cumulative distribution function of the Gaussian random variable is from this equation capital Fx of x is equal to 1 minus 1 minus, and what is this equation? This is the Q function. Sorry. Now here the expression of the Q function. The expression of the Q function, Q of K is equal to 1 by square root of 2 pi integral K to infinity e power minus x square by 2. So from that equation, thus this is the equation. So therefore, applying the Q function expression from this equation, the distribution function of the Gaussian random variable is capital Fx of x is equal 1 minus q of x minus m by sigma. So this is the first solution of the this equation. First solution of this integration, this equation. Next, second solution of this equation is in first solution we are considering x minus m by sigma is equal to p. Now here we are considering x minus m by root 2 sigma is equal to p. So that is the difference between first solution expression and second solution expression. In the first solution we are considering p is equal to x minus m by sigma. Now here we are considering x minus m by root 2 sigma is equal to p. So from this equation, x minus m is equal p into root 2 sigma, differentiating with respect to x, dx is equal to root 2 sigma dp. So in this equation, substitute lower value of x and upper value of x, we get lower value of p and upper value of p. So that are at x is equal to x, p is equal to x minus m by root 2 sigma. And in this equation substitute x is equal to infinity, then p is equal to infinity minus m by root 2 sigma. So infinity by root 2 sigma infinity. So therefore applying these considerations into this equation, we get capital Fx of x is equal 1 minus 1 by square root of 2 pi sigma square integral x minus m by root 2 sigma to infinity e power, now here x minus m by 2 sigma square, x minus m whole square by 2 sigma square is written as x minus m by root 2 sigma whole square, x minus m by root 2 sigma whole square. So that is x minus m by root 2 sigma is p. So therefore e power minus p square dx is equal to root 2 sigma dp. Now here the denominator term square root of sigma square is sigma, numerator and denominator root 2 sigma is the cancel, and the remaining expression is capital Fx of x is equal to 1 minus 1 by square root of pi integral x minus m by root 2 sigma to infinity e power minus p square dp. So now here the second term multiplying numerator and denominator by 2, we get Fx of x is equal 1 minus 1 by 2 into 2 by root pi integral x minus m by root 2 sigma to infinity e power minus p square dp. But we know that we have the complementary error function. The standard expression of the complementary error function expression is error function of k is equal 2 divided by square root of pi integral k to infinity e power minus x square dx. So this is the standard expression of the error function. So, and this is the standard expression of the error function. So using this error function expression, now we are the second term in this equation. In the numerator 2 is the missing term. So because of that, in this equation, in the second term, multiplying numerator and denominator by 2, we get this expression. So using this error function expression in this equation, we get so now here in place of k, here what term is there? X minus m by root 2 sigma. So therefore distribution function capital Fx of x is equal 1 minus 1 by 2 error function of k. In place of k, what value is there here? X minus m by root 2 sigma. So this is the second solution of the distribution function integration. So this is the concept of Gaussian distribution.